Very important for modern research to be able to do that. We're somewhat unique in comparison to other universities that typically have a department structure. We're a interdisciplinary program which spans across several schools: the engineering school, the medical school, and natural resources and policy, public policy. So we're quite broad across the campus, and our students can do their research in a very transparent way and flexible way in any of several different departments and labs across the campus, and this gives it great flexibility and is the kind of training that's really important now for graduate students. When they go out into the world, they're going to be working with many different kinds of scientists and engineers from all kinds of disciplines, so it's important that they start their work in their graduate work to accommodate that kind of way of working, which is so important these days. The University of Michigan is a wonderful place for doing interdisciplinary research, and the reason is that it's got a very, very large breadth of research projects going on in many different areas. For example, about a month ago, the research volume at the University of Michigan had just surpassed $1 billion per year, which I believe is the largest research volume of any university in the US and perhaps in the world. And it's, the goal of applied physics, of course, is to take basic discoveries and basic understanding of physics and to take them into areas where they've never been before, and to produce new applications which some of which will become the basis of new technologies. And our students in applied physics are coming from a very broad area of academia. They're coming from different countries, from all over the world, and what we're really looking for in our program are students that would be committed to sort of reaching out beyond the confines of any particular discipline and connecting things up in a way that hasn't been connected before, bringing disciplines together. Typically our students are not always from within physics. Sometimes they'll have a major in physics and maybe a minor in electrical engineering or engineering physics, or a major in mathematics and a major in some physical science like chemistry or engineering physics, and have the kind of drive that they would want to further the goals of doing interdisciplinary research when they come here, and that's the kind of student that we really like to see here at the U of M. So the University of Michigan, is as I was saying, is a very broad, large research effort with a huge amount of research going on. What we've tried to do in the applied physics program is create a kind of microcosm within that large environment that is very supportive and looks out for individual students' needs, treats students as individuals, which will eventually go through the PhD program to do some of the best work that they've ever done and come out with a very strong research dissertation. And our goal here is to make sure that that's done successfully and to give our students the kind of resources that they need to be able to do that. And the success of our students is research projects that we couldn't even dream about when the program started. For example, we didn't know we'd be doing work in nanostructure quantum dots, for example, because they hadn't yet been dreamed up. We didn't know that we'd be contributing to the energy policy of the United States through our work in with this U.S. Senate and committees of within Congress that deal with these issues. Some of our students take internships in Washington to help with those kind of policy issues and to learn about how policy is made in this country. So a very exciting range of opportunities. It's never really been a better time for research than at the present time, and so tremendous opportunities right now. The research climate in the United States is very, very promising, very active. There's great support at both the state and the federal level, and we foresee our program continuing to grow with the kinds of applicants to the program that we've been getting recently. We have no doubt whatsoever that this is really going to be an exciting era for graduate training, and we welcome applications from you all.
I came to Michigan in 1998 and I do semiconductor physics. In physics department we are interested in sort of fundamental aspects of materials. However, a lot of the materials we do study end up being used in real life. For example, gallium nitride or light-emitting diodes, and sooner or later they're going to be replaced. They're going to replace the compact fluorescent lights. Actually, Ann Arbor is the first city to put gallium nitride LED lights on the street. So the things we do, even though might not look like applied in the long term, they end up being used in real life, and the things we do impact society. It's really perfect for those of us who want to do research on the edges. And the students who want to do such research are really well suited to join the applied physics program, because when they come to the program, they have the complete freedom to choose. Furthermore, the program is really flexible in that we look at the research of the student and then engineer the courses they take, and we are able to deal with each student individually. When they do finish, they have the academic path, which is open to all PhDs, but they can also go pursue their ambitions in industry. And if you have a nice idea, you can go start a company and change the world.